Hello dear students, for the first grade exam I chose 30 questions, but without definitions there are only 22 questions in total. So okay, let's start. Question 11. What is the torque produced by 5 Newton force perpendicular to the 2-meter spanner as shown in the figure? So here we just use torque formula, which is F times distance times sine alpha, the angle between the force and the distance from the pivot. Yeah. So here it is perpendicular. This force is perpendicular to the spanner. That means the torque will be just equal to the product of force and distance, and torque is equal to 5 newtons times the distance 2 meters. So 10 newtons times meters. That's it. Question 14. A force of 15 newtons is applied to 0.4 meter road that can turn about the point O in the horizontal plane as shown in the figure. Find the torque produced by this force. So again, the same formula. Torque is equal to F times distance times sine alpha. So force is equal to 15 newtons, distance is equal to 0.4, and alpha is equal to 53 degrees. So let's just calculate it. So torque is equal to 15 newtons times the distance 0.4 times sine of 53. Torque is equal to 20 times 0.8, which is equal to 16 newtons times meters. That's it. Question 16. So here the beam is given, which is fixed on a pivot, and 3 different forces are applied to it. And here we need to define total torque of the system here. And here we need to use, we need to apply torque net equation, which is the sum of all torques. There are 3 torques, yeah? So it will be torque 1 plus torque 2 plus torque 3. And also we need to take into account their directions. So torque net will be equal to sum of torque 3 and torque 2, and the difference of the last one, torque 1, yeah? And let's open up this formula. So torque net will be equal to torque 3 is the force 3 times the distance is d over 2 times sine 53, and minus the torque 2. Torque 2 will be F2 times it's on the edge, so it will be just distance times sine 90, and the last one is, this is and minus F1 times 0.5 times 3 times sine 37, and let's calculate it. So torque net will be equal to F3 is 5 newtons times d over 2 is 1 meter times sine 53 is 0.8, and plus F2. F2 is 10 newtons times, what was it? Distance is 2 meters times just 90, it's just 1. So then it's adding, yeah, a minus F1 is 20 newtons times 1.5 meters times sine 37 is 0.6. So torque net is gonna be 4 newtons times meters plus what is this? 20 newtons times meters minus 30, it's 18 newtons times meters, so it will be equal to 6 newtons times meters, and it is positive, so meaning total torque is in a positive direction. Question 20. A 2-meter long rod is suspended by a rope, is at rest as shown in a figure. If the weight is 120 newtons, what is the tension T in the rope? So we need to find the value of the tension here. For it, we need to solve this question, guys, we need to apply the second condition of equilibrium, which is net torque is equal to 0. In this question, it is 0 because the system is in equilibrium, it's not moving, it's not accelerating, so it will be equal to 0. And now we need to show how many torques are there in this question. So for it, we need to show how many forces firstly. So we have downward force, weight of the object, and second one is the tension, but to define the torque we need only vertical component of the tension, so which is tension by X. That means these two forces are in combination makes torque net 0. Yes, so torque net is equal to 0, which is equal to the torque of the weight, and I need to write torque of the tension firstly. Torque of the tension X minus torque of the weight. So that means torque tension by X is equal to torque of the weight, like this. And let's open it up. Torque tension by X is equal to tension by X times the distance is just a D, which is equal to the weight times distance over 2. So tension by X can be written as tension times sine alpha times D equal to weight times D over 2. So the tension is equal to, here we can cancel D distances, yeah? So it will be work over 2 times sine alpha, which is equal to 120 newtons over 2 times sine alpha should be 0.6. So it's equal to 100 newtons of tension. Question 24. One end of a beam of negligible mass is hinged to a support and the other end is suspended from the ceiling with a string. If the 60 Newton weight is located on the beam, as shown in the figure, find the tension in the string. First question. And B, find the force applied by the support to the beam. So to solve this question, again we apply second condition of equilibrium. Yeah, torque net must be equal to 0. Torque net must be equal to 0. And now let's show all the forces. Here we have weight of the object, which is located, so as you can see, this whole beam is divided into 6 parts, yeah, 6 equal parts. One, let's say, third one, fifth and sixth one, yeah. So here, let's say this weight is 4, 1, 2, 3, 4, yeah, 4x at a 4x distance from the pivot, and the tension is applied at, in total, 6x distance from the pivot, yeah. And now let's make the equation. Torque net is equal to 0 is equal to torque of the weight minus torque of the tension. and torque of the weight is equal to torque of the tension, and here torque of the weight is equal to weight times 4x is equal to tension times 6x. So the tension is equal to weight times 4x over 6x, so it's equal to weight over 3, yeah, and just put the numbers. So 2 times, what was the weight, 60 newtons over 3, so it's gonna be 40 newtons of the tension. Yes, so the tension is upwards, this tension. Yes, tension is 40 newtons of and upwards. And the second question, find the force applied by the support to the beam. So it's asking to define the reaction force at this point, R, let's say Ry, because it's just vertical. And so here, if you see there are 3 forces in total, yeah? Tension, Ry, reaction force by Y, and the weight. So the sum of them by the first law of equilibrium must be equal to, by the first condition of equilibrium must be equal to 0. So force net is equal to 0, and which is equal to the sum of all of them by taking into account their directions. So 40 newtons of force, tension, plus Ry plus, minus the weight. Weight is equal to, let me just write the number, equal to 60 newtons. So Ry is gonna be equal to, Ry is gonna be equal to 20 newtons, and it is upwards. Question 26. A uniform rod weighing 10 newtons is suspended by 2 ropes. Shown in the figure, what is the ratio of the tensions in the ropes T1 over T2? So probably in this question, tension 2 is more than tension 1 because more mass is on the side of tension 2, yeah? But here we need to define the ratio of them, yeah? Let's try to solve it. Firstly, guys, we need to show the center of mass of the beam, so it will be exactly on the center, so here. So we assume that 10 Newton force is applied from this point downwards. Okay. The second, and now in order to define the tensions, each of the tensions we have to choose 2 different pivots for 2 different tensions, as I said. So in order to get tension 1, the pivot must be at point T2, under T2. And in order to get tension 2, the pivot must be here at this point. So let's firstly define T1, yeah? So to get it, we have to make second condition equilibrium equation. So torque net of the system is equal to 0, so it's equal to tension 1 times the distance. So here the beam is divided into 4 equal parts, and let's assume them as just x, and x. Okay, so tension 1 is equal to, torque net is equal to 0 is equal to tension 1 times it is 3x away from the pivot, and second one is minus the weight of the object, weight times it is 1x, yeah, just x distance away from the pivot, like this. So tension 1 times 3x is equal to W times x. So tension 1 will be equal to, what is the weight? 10 newtons force, 10 newtons over 3. This is the tension 1. And now let's solve it for tension 2. Again, torque net is equal to 0 is equal to. So in this case, our pivot is changed. Our pivot is at this point, pivot here. And now tension 2 times, it is again 3x distance away, and minus the weight, and it is, instead of just x distance, here it is in 2x distance, yeah, away. So tension 2 times 3x is equal to weight times 2x. So tension 2 is equal to 20 over 3 newtons. So let's make a proportion. So tension 1 over tension 2 is equal to 10 over 3 over 20 over 3. So which is equal to 3 and 3 will be cancelled, and 10 over 20, which is equal to 1 over 2. Question 29. A uniform sphere of weight 28 newtons is attached to the frictionless wall by a string, as shown in the figure. If the sphere is in equilibrium and the extension of the string passes through the center of the ball, calculate the tension on the string and the reaction force of the wall. So here we have to apply conditions of equilibrium, and in order to get the tension value we have to use the second condition of equilibrium. But for it we have to firstly to make the equation, we have to find the torque. Here the pivot is will be located here. This is our pivot. And what else? That means from this pivot, it's not attached, but still we can consider it as a pivot. And downwards, it is pulled by a force of 28 newtons. It's a weight. And upwards, it is pulled by tension by Y. Yeah, vertical component of this tension here. So to get the value of the tension, we can first find the tension by Y, or we can just make the final equation by just using the tension itself. Yeah. Now let's make it. So torque net is equal to 0. So which is equal to, there are only two forces. So torque Y minus torque of the tension by Y minus torque of the weight. So that means torque tension by Y is equal to torque of the weight. So torque tension by Y can be written as tension by Y times the distance from the torque, distance from the pivot for tension by Y and for the weight are the same. It's just D. Yeah. So tension by Y times D is equal to weight times D. So that means tension by Y is equal to weight. Tension by Y can be written as tension times since this angle is 37, we can use cosine 37 is equal to weight. So tension is equal to weight over cosine of 37. Here it is 28 newtons over 0.8, which should be 35 newtons of tension. Second, B. The reaction force of the wall. Reaction means this ball, this total ball, is applying a force, is exerting a force on the wall, which is the force, and opposite to it, the wall is exerting what? The reaction force R by X, let's say. So let's define it. So that means Rx by the third law of motion, by the third law of Newton should be equal to R should be equal to tension by X, because there is only one force which is opposite to it, which is tension by X, this second component of tension here. So tension by X is equal to Rx is equal to tension multiplied by sine of 37. So it is equal to, Rx will be equal to tension 35 newtons times 0.6, which is equal to 21 newtons. Question 31. A uniform 2-meter long wooden beam with a weight of 140 newtons leans against 1-meter high wall, as shown in a figure. There is no friction at point B where the beam touches the wall. If the beam is in equilibrium, calculate the reaction force NB of the wall applied to the beam at point B, and the normal NA which the ground exerts on the beam at point A, the friction force which the ground exerts on the beam at point A. So to solve this question, guys, we need to solve A, we have to use the second condition of equilibrium, and for it the point A will be our pivot. And next, now let's count all the forces. And one thing you have to know, the weight will be exerted exactly from the middle of the beam. That means from the center of mass. Let's say it's somewhere here, and it is downwards, like this is the weight of the beam, yeah. And here reaction force applied from the point B will be exactly at right angle, because there is no friction with the wall, that's why. Okay, and now what should we do? We have to apply, as I said, second condition of equilibrium, and for it we have to show all the forces which are necessary to get the torque, yeah. So here pivot is here, that's why we just take the reaction force itself here, and but for the weight it will be not the weight itself but one component, this one, it is weight by y. If we consider that this is x and this is y. Okay, so weight by y, and as you can see there are two forces, weight by y and weight by y and Rx are determining the final torque of the system, and some of them must be equal to 0. And let's make the equation. So as I said, torque net of the system is equal to 0, is equal to torque of the reaction force, torque of the weight by y minus torque of the reaction force. So torque of the weight by y will be equal to torque of the reaction force, and let's open them. Torque of the weight by y will be equal to weight by y, and the distance here, distance from the pivot, as you guessed, should be equal to, if it is exactly on the middle, it will be equal to 1 meter, yeah. So let's write it as 1 meter here, and torque by R will be equal to reaction force, let's write it as NB times, but the distance from the pivot, distance from the pivot to the reaction force N is not given. Let's take it as, I don't know, let's take it as D. It's not given, but we can find it by using this angle and this height here. This height here, okay? We use trigonometry rules here, so it will be like this. We know that, I will write it somewhere here. Okay, so we know that sine 53 is equal to opposite side over adjacent side. So sine 53 is equal to 0.8, which is equal to opposite side 1 over 1.2 over the distance. So d is equal to 1.2 over 0.8, which is equal to 1.5 meters. It will be 1.5 meters. So the distance from the reaction force to the pivot will be 1.5. And multiplied by 1.5 meters. You know, NB that we are looking for will be equal to weight by y. And here also, we have to define what is weight by y. Here, the angle here will be equal to, the angle here will be equal to 53 degrees. So we can get weight by y by, let's write it like this before making calculations. So weight by y will be equal to weight times the cosine of 53 times 1 meter is equal to NB times 1.5. So NB will be equal to, I will move this 1.5 to the next side here. So weight by y is, weight itself is 140 newtons times 0.6 times 1 meter over 1.5. So let me calculate it. 140 times 0.6 over 1.5. It's equal to 56 newtons of force. This is the answer of the A, yeah? Let's solve B. Let's solve B. The normal force NA, which the ground exerts on the beam at point A. So to solve it, let me erase just a second. Something for it. So what does it say? The normal force NA, which the ground exerts on the beam at point A. So it's like it will be NA at this point. And what do we have to do here? We have to apply first condition of equilibrium. So we have to show all vertical forces, yeah, because horizontal forces doesn't affect on the normal, but only the vertical ones. So we have the normal A itself, the vertical force, and we have the weight, and we have this one, RY, like reaction force at point B, yeah? So three forces in combination must be equal to, sum of them must be equal to 0, yeah? And let's make the equation. So as I said, just a second. So F net is equal to 0 is equal to the sum of them. n b plus na minus the weight of the object, and that's it. And that means na is will be equal to weight minus nb. We know the value of the weight, but we don't know what is the value of the nb. nb is this one, ry. I wrote it ry, or you can write it as nb by y. Sorry, by y. I forgot to write nb by y. Also here. So that means we have to get the second component of we have to get vertical component of this one. Yeah. How do we solve it? And if we know that this angle, the angle here, is 37 degrees, so that means this tiny angle here will be also 37 degrees, and this left angle will be equal to 53, because this angle is a right triangle. I'm sorry, this angle is right angle. That's why the angle between the R and NBY will be equal to 53 degrees. So that means we can write it in this way. NA will be equal to weight minus NB itself times, here we use cosine of 53, because the angle is between these two vectors, yeah? So that's it. NA will be equal to 140 newtons minus 56 newtons times 0.6. Let me calculate it. Minus 56 times 0.6. It will be equal to 106.4 newtons of force. This is for B. Yeah. Let's solve it. Let's solve C. Yeah. The friction force F, which the ground exerts on the beam at point A. Friction force means, I will draw it by a blue color. It's here. Friction force. Friction force compensates, like it keeps the system in equilibrium, yeah, here. And opposite to it, horizontally, we have only one force, which is this one, which is the NB by X. So value of the NB by X must be equal to value of the friction by X, just friction, let's say. So I will write it like this. N B by X will be equal to the friction. So now let's define NB by X. It will be equal to by X is equal to NB times the sine of 53, which is equal to, let me calculate, 56 times 0.8, which is equal to 44.8 newtons. And this is the answer. Question 39. Homogeneous spheres K, L, and M are shown in a figure in XY coordinate system. If each side of the squares is 1 centimeter long, find the coordinates of the center of mass of the system formed by the spheres. So here we just use the center of mass formulas, which is for X coordinate, which is XCM is equal to X1 mass 1 plus X2 M2 plus X3 M3 over the sum of the masses, yeah? This is just write mass total. And this formula is the same for y coordinate, yeah? And let's solve it. So we have x1, let's say it is k, yeah? We have distance of 2 times 3 kilograms plus and m, which is 1 centimeter away, multiplied by 2 kilograms, and I subtract the last one because it's on the negative side. Subtract 2 times 1 kilogram over sum of their masses is 6 kilograms, so it will be equal to 6 plus 2 minus 2 over 6, which is equal to 1 centimeter. And let's solve it for YCM. It will be K is 2 times 3 minus M is on a negative, 1 times 2 and plus L is 2 times 1 over total mass of them. It will be equal to 6 minus 2 plus 2 over 6 will be equal to 1 centimeters. So the coordinate of the center of mass will be here, 1 and 1, yeah? 1, sorry, like by x it's this line, and by y it is this line, so intersection of them will be the center of mass. Question 49. The homogeneous cable is bent twice between points C and F, as shown in the figure. If each side of the squares is 1 centimeter long, find the coordinates of the center of mass of the cable. So here I try to draw it in a bigger size, and I also wrote all the coordinates and all the masses. I mean, this cable, instead of considering a cable, we have to consider points. So, for example, the cable segment AB can be just considered as the point M1, which is, for example, here, and so on, M2, M3, and so on. But all of them have the same mass except the last one, because the last one is bent twice. That's why M5 will be double mass. Okay, so let's make the equations. We use the center of mass equation. So x, we solve it for x coordinate and then for y coordinate as well. XCM will be equal to, our coordinate origin is here, point O, and we are assuming that 3 squares make 1 centimeter, but coordinates are already written here, so it's not a problem. So XCM will be equal to M times M1, yeah? M1 is M, and times 1 plus M times 3 times plus M times 2. Sorry, I'm solving by X, so it will be M times 2 plus M times 3 plus M times 4 plus 2M times 5, and over total mass it is 6M. So XCM will be equal to 1 plus 2 plus 3 plus 4 plus 10 over 6, which is equal to 6, 20 over 6, which is equal to 10 over 3, which is equal to 3.3 centimeters. And we solve it in the same way for y-axis. It will be equal to m times 2 plus m times 3 plus m times 2 plus m times 1 plus 2m times 2 over 6. So YCM will be equal to I forgot to write m here. Here. So it will be equal to 2 plus 3 plus 2 plus 1 plus 4 over 6, which will be equal to 4, 8, it's 12 over 6. It's 2 centimeters. That means the coordinates of the center of mass will be at 3.3. 3 is here. 3 point, let's say it's somewhere here. Yeah. And 2. 2 is exactly this line. So intersection of them will give the center of mass. Question 44. Find the center of mass of the uniform plate shown in a figure. So here it's not an ordinary shape. It is like complex shape, yeah. So that's why we need to divide it into 3 parts. Here, I think it's just enough to divide into 2. So like this, we have a triangle and a rectangle. First step, we have to find their masses, but mass is not given, but we can show it as the area, because area is directly proportional to its mass. Yeah. So we have rectangle. Mass of the rectangle is directly proportional to the area of the rectangle. So which is equal to A times B, let's say, 2 sides, yeah, which is equal to 4 units times 2 units, so it is 8. We use this 8 instead of mass. So mass of the triangle is directly proportional to the area of the triangle, which is equal to the height times the base. Yeah. So because we can use this equation because it is isosceles triangle. Yeah. So the height is 3 and the base is 2, which is equal to 6 let's say centimeters squared. So I'm sorry, I forgot to divide it by 2. So it's equal to 3. And here also we know the masses, and now we have to find the center of mass of them. Yeah, here rectangles, center of mass will be at the intersection of the diagonals. The triangles center of mass will be at intersection of the medians, so it will be here. How do we know it? Because medians, intersection of medians divide medians itself into proportion of 2 and 1. That's why 2x and 1x. So we know, that's why we know the exact point here. And now let me write also the coordinates. So CM of the rectangle is at 1 to 2. So and center of mass of the triangle is at 3 to 1. Now we know the mass and we know the coordinates. Now we can just make the equation here. So xcm will be equal to 8 times 1 plus 3 times 3 over total mass is 11, which is equal to 8 plus 9 over 11 is equal to 17 over 11 centimeters. And ycm is equal to 8 times 2 plus 3 times 1 over 11. It's 16 plus 3 over 11. It's 19 over 11 centimeters. So these are the answers. Question 48. What is the coordinate of the center of mass of a uniform piece of cardboard which is cut into the shape shown in a figure? So this is the complex shape, and we have to divide it into shapes, into more simple shapes. Yeah. So here I can divide it like this. So we have one shape here, also here, and here we have this shape, a third shape, and the last one is here. And now we can define their we can find their center of masses. Yeah, let's say center of mass of these two red shapes will be at this point. Why? Because they're identical, they have the same mass. That's why I can just say that it is here. And for the rectangle, first bigger rectangle, it will be in the middle, and for the square it will be on the middle too. So we have three different center of masses with three different masses also. So this one, mass of this one will be just m. Mass of the second one will be, if you count, there are 6 squares. That means the mass of it will be 6m. The last one will be 2m. And now let's find. Okay, I will just make the equation. I will not write the coordinates. Okay. So xcm will be equal to 2 times the mass 2, yeah, times the distance is 2.5 plus 6 times 7.5 plus 12.5 times m. I'm sorry, not m, just 1. And over total mass of the shape is 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7. It's 9, yeah. So if you add all of them, you should get, I don't know, let's calculate it, plus 7, 6 multiplied by plus 0.5 times. You have to get 62.5 over 9. It's probably approximately 6.9 centimeters. And we have to make the same for ycm. So it will be mass of 2 times 10 plus 6, mass of 6 times 10 plus mass of m, which is 1 times 12.5 over 9. So it will be equal to 20 plus 60 plus 12.5, it will be equal to 92.5 over 9. It's equal to 10.27 centimeters. So these are the answers. Question 5. A 2 kilogram object which is at rest on a frictionless horizontal plane is acted by a force of 10 newtons at the angle of 37 with the horizontal. If the object moves a distance of 2 meters, what is the work done by a force of F? So here, this force is acted at angle, that means it's between horizontal and vertical. That means in order to get positive work done by a force, we have to use only the component of the force which is parallel to the displacement. So here, in this case, the force is applied at angle, that means it is moved by a horizontal. So meaning we have to measure the work done only by Fx. So work will be equal to Fx times the distance. So work will be equal to F times cosine of 37 times distance. So work will be equal to 10 newtons times 0.8 times 2 will be equal to 16 joules of work. Question 8. An object moves horizontally 4 meters under the effect of three forces shown in the figure. Find the work done by each force and then find the net work done by the net force. So here we have to take into account their angles with the horizontal because the object moves by a horizontal. So that means only horizontal forces and horizontal components of the forces give a work or effect on a motion because there is no friction. So here we start from work 1. Work 1 is equal to F1 times cosine of the angle. Why? Because we need only horizontal component of it, and times the distance that's rated as d. So work 1 will be equal to 50 times cosine 0.8 times 4, which is equal to I think it's 160 joules of work. Then yes, work 1 here. So work 2. Here work 2 is just perpendicular, that means it doesn't affect on the motion. We can just say it's just 0, or also we can make the equation which is F2 times cosine of 90. Since cosine 90 is 0, the work will be again 0. Work 3 is equal to here third force is in a negative direction to the displacement. That means the work done by it will have a negative sign. It has a negative sign, so it will be F3 times the distance. It will be equal to negative 30 times 4. It's 120 joules of work. Negative 120 joules of work. And question B, it says the net work done by the net force. So it will be just net work is just sum of all works, and so on. Net will be 160 joules minus 120 joules. It is 40 joules of work. 10th question. A force of 15 newtons is applied to a 2 kg block resting on an inclined frictionless plane. If the block moves 5 meters under the effect of the force, find the work done by force of F and the work done by gravitational force. Does the reaction force from the surface do any work? So for the first one, the work done by a force is applied parallelly to the surface. That means our formula for it, A, will be equal to just force times the distance traveled, yeah? Work done by the force will be equal to force is 15 newtons and times the distance is 5 meters. So it's equal to 75 joules of work. It is positive 75 joules of work. Second, the work done by the gravitational force. Here, this object is pulled downwards by gravitational force, yeah, Fg. And this Fg, work of it will be negative because it is moving in an opposite direction. I mean, like it is pulling downwards, but it is moving up. That's why the work done by Fg will be negative. So here we have to define for how many meters it moved up. So that means I need to find this height. So this height can be found by looking at these angles. This angle is 37, and we know that sine, let me write it here. So sine 37 is equal to opposite side length over hypotenuse, yeah? So it means in this case it is opposite side is h over the hypotenuse is 5 meters. So it's equal to, so the height is equal to 5 times 0.8, 0.6, so it will be 3 meters. And now we use the 3 meters in to get the work done by gravitational force. So work done by gravitational force will be equal to mass times g times the h, but with a negative sign. So it will be mass is 2 times 10 times 3. It will be negative 16 joules of work. And this is for B and C. Does the reaction force from the surface do any work? So here, reaction force is the force which is perpendicular to the surface. So means it doesn't do any work because it should be parallel to the displacement. So I will write it as R, work done by normal force is equal to 0. Question 12. The force versus position graph of an object on a horizontal frictionless plane is shown in a figure. Find the forces applied to the object parallel to the direction of its motion. Find the work done by the force between 0 and 2 meters. Okay, so to solve this question, you need to know that area under the line gives in a fx graph, area under the line gives the work done. Okay, so that means work done for question A will be just 6 times 2, which is 12 joules. And the work for B, question B, will be equal to, it's the area here. It will be 6 times 2 over 2, which is 6 joules. And work done on the, for the question C will be area here, 408, yeah. So it is under the coordinate system, so it will be with a negative sign. It will be negative 6 times 8 minus 4, which is negative 24 joules. And the last one, between 0 and 8, like total work done, it will be the sum of all of them. Work 1 plus work 2 plus work 3. So it will be 12 plus 6 minus 24, which is negative 6 joules of work. 18th question. One of the lorries is half the weight of the other, but it is moving at twice the speed of the other. Which of the lorries has more kinetic energy? So firstly, let me write the kinetic energy formula, which is 1 over 2 mv squared. Yeah. So kinetic energy of the first lorry is gonna be 1 over 2. It's moving, it has the mass of W and the velocity of v squared, and kinetic energy of the second one is 1 over 2 times mass is W over 2, but the speed is 2v squared. So if I open it, it will be 1 over 2 W over 2 times 4v squared, and kinetic energy 2 will be equal to W v squared. So as you can see, this W v squared is actually equal to kinetic energy 2. Yeah, kinetic energy of the second lorry. So I can replace it there. So kinetic energy 1 will be equal to half of kinetic energy 2. So the kinetic energy of the second lorry is twice of the first one. Question 21. While initially resting on a frictionless horizontal plane, a 20 kg case is pulled 25 meters by a 10 Newton force. What is the work done? What is the speed of the case at the end of the 25th meter? How many seconds does it take for the case to reach this speed? So we use different formulas. We use here also we have to use kinematics equations. Okay, solve it. For A, what is the work done? Work is equal to force times the distance. So work is equal to 10 newtons times 25, which is 250 joules of work. And B, what is the speed of the case at the end of the 25th meter? It will be, here we have to, first we have to determine the acceleration. Acceleration is equal to force over mass, which is equal to, so here acceleration will be equal to 10 newtons over 20 kilograms. It will be equal to 0.5 meters per second squared. Now we have the acceleration, we have the distance traveled. We can use this equation. Velocity final squared is equal to velocity initial squared plus 2as. and velocity final squared is equal to 2as because initial velocity is 0, and velocity final is equal to 2as the square root, so it's equal to 2 times 0.5 times 50, 25 in square root, it will be equal to 5 meters per second. And see how many seconds does it take to decay to reach the speed. So here we can use this equation: velocity final is equal to velocity initial plus at, and it will be simplified because velocity initial is 0 and time will be equal to velocity final over acceleration, and velocity final is 5 over 0.5, which is 10 seconds. Question 35. A 2 kilogram object is released from the top of a smooth inclined plane, which is 6 meters high. When it reaches the bottom of the inclined plane, what is the work done by gravitational force? What is the change in potential energy? So, work done by gravitational force will be equal to, so this object is pulled downwards by 20 newtons of force, 20 newtons of gravitational force because the mass is 2 and we take gravitational acceleration as 10. So gravitational force multiplied by distance traveled. So work done by gravitational force will be equal to mass times g times the height. It will be equal to 2 times 10 times the height is 6, so it is 120 joules of work done by gravitational force. And what is the change in potential energy? So for it we have this formula. Work done by gravitational force is equal to negative delta PE, negative change in potential energy. So that means negative delta PE is equal to work done by gravitational force is equal to 120 joules. So negative delta PE is equal to 120 joules, or delta PE is equal to negative 120 joules. 36th question. 60 kilogram boy is climbing 1 meter to the top of the stairs with the constant speed as shown in the figure. How many joules of potential energy does the boy gain? How many joules of work does the boy do against the gravity? So here we just use the delta P, the change in potential energy formula. So delta PE is equal to potential energy final minus potential energy initial. So since potential energy initial is 0, delta PE will be equal to just potential energy final, and which is equal to mass times g times h. So delta PE is equal to 60 times 10 times 1, which is 600 joules. A, the answer for the A. And B, how many joules of work does the boy do against the gravity is the same. Work done by boy is equal to just 600 joules. 44. Question 44. A 2 kilogram object slides down on a smooth hill as shown in the figure. What is the velocity of the object at the bottom? So here we have to apply conservation of mechanical energy. Mechanical energy initial is equal to potential energy initial plus kinetic energy initial, and this mechanical energy will be conserved till the end of the motion. So initially kinetic energy is 0 because it starts from rest. So that means mechanical energy initially is just potential energy, which is equal to mgh. And then this energy will be converted into kinetic energy. So we can say mgh will be equal to mv squared over 2. So we can cancel masses, and 2gh over 2gh in the square root will be equal to the velocity. Velocity is equal to 2 times 10 times 45, and then the square root will be equal to 900, which is equal to 30 meters per second. 30 meters per second. 47th question. An object of 400 grams is launched as shown in a figure making a certain angle with the horizontal. If the maximum height of the object can reach 5 meters, and the kinetic energy at its maximum height is 20 joules, what is the vertical component of the initial velocity? The kinetic energy of the object at the moment it launches, the work done by gravity from the point where the object launches to the point where it lands, the kinetic energy of the object at the moment it strikes the ground. So to solve this question, we have to apply the kinematics equations or the one-dimensional motion equations. So it says, first question is to find the vertical component Vy, and we can solve it by using these equations. So here, you know that velocity final squared is equal to velocity initial squared plus 2as, and for one-dimensional motion it will be velocity final by y squared will be equal to velocity initial by y squared plus 2gh. And since velocity final is 0, we can write it velocity initial by y squared will be equal to negative 2gh. So here velocity initial by y will be equal to negative 2gh in a square root. So here we have to put, since the motion is against the gravity, we have to put negative 10. So that means it will be cancelled with this negative sign here, and we have left with 2 times 10 times 5, and it's equal to 10 meters per second. So initial velocity by y vertical velocity is 10. Next question. B. The kinetic energy of the object at the moment of launch. So for it, we have to use this information. At the maximum height, the kinetic energy is 20. We know that in two-dimensional motion, the horizontal component of the velocity doesn't change. So meaning horizontal kinetic energy also stays constant. Okay, so meaning we can find the velocity, horizontal velocity, by using this 20 joule. Yeah, so kinetic energy horizontally, by x is equal to 1 over 2, 0.4 times the velocity squared. So 20 times 2 over 0.4 is equal to velocity squared, which is equal to 100 squared, which is equal to 10 meters per second. 10 meters per second. So look, we have two components of the velocity, like velocity by y is equal to 10, and velocity by x also is equal to 10. We can use, if we use Pythagorean theorem, velocity will be equal to 10 squared plus 10 squared in under root. So it will be equal to 10 root of 2 meters per second. Now we can use it to define kinetic energy initial, which is equal to 1 over 2 times 0.4 times 10 root of 2 squared. So it will be equal to 40 joules. 40 joules. Next, the work done by gravity from the point where the object launches to the point where it lands. So when it moves up, when the object moves up, the gravitational force does negative work. When it moves down, the gravitational force does positive work. So we can see that in these two cases, till this point, gravitational force does negative and positive work, and they can cancel each other. And if we define the work done by gravitational force from this point till here, we define total work done by gravitational force. So it will be work done by gravitational force will be equal to the distance. We can use delta PE also. It will be negative delta PE. It will be equal to potential energy final minus potential energy initial. So delta PE is equal to 0. Potential energy final is 0 at the bottom, minus potential energy initial is mgh, let's say 1. So with a negative sign, and these negative signs will cancel each other. So delta PE, or work done by gravitational force, will be equal to just mgh1. So mass is 0.4 times 10 times h is 15 here. It's 15. So it is 4 times 15 is equal to 60 joules of work done by gravitational force. Last question, the kinetic energy of the object at the moment it strikes the ground. So here we can apply mechanical energy conservation laws to get, in order to get the total final kinetic energy, yeah? So here at the same level, potential energy is the same, meaning, for example, potential energy at this point, which is 60 joules, is the same with this point too. So initially, mechanical energy of the object was 60 joules plus the kinetic energy, which is 40. So mechanical energy initial is 60 joules of work plus, 60 joules of potential energy plus 40 joules of kinetic energy, which is in sum makes 100 joules of energy. But when it reaches the point, reaches the bottom, all that energy converts into kinetic energy. So mechanical energy final is kinetic energy, which is 100 joules, because it conserves